So here are some examples of two-dimensional motion problems. So some general notes: if ever you see a vector, break it into components. This is a very important step, and it'll happen a lot. Use both sets of your equations. You have x and y components, use them. Okay? And then the third part, work with your variables first, except zeros. This makes debugging your problem so much easier, and you can follow through what's going on. And we'll see a really good example of this in a moment. So there are three motion equations we're going to use. And I'm going to use subscript x, but you can use whatever subscript x or y that you need. So the first one is your final velocity is equal to your initial velocity plus your acceleration times time. Your second equation, which turns out to be one of the more useful ones, your x final minus your x initial equals your initial velocity in that direction times time plus 1/2 ax t squared. Now in the x equation for projectile motion, this is really useful, as when this a goes to 0, works out alright, makes things a little bit easier. And then your third equation that you're going to use is when you don't have time, and that's v final squared plus v initial squared plus 2 times your acceleration times your change in x. And remember that this change in x is just your final x minus your initial x. So let's see what we can do with these. Now before we jump right in, here's a couple things you should know. First thing you do, write down your givens, your unknowns, and draw a picture. So this gives you a very nice setup to work with. Alright, lets you know what's going on. Next, think about the principle and the idea. So this kind of gets you thinking about, oh, where should I look? What type of problem and what type of formula are you going to use? Right? When you look at that formula sheet, the one that's posted on Blackboard, I would always have that with you, by the way, whenever you're working homework. It's the same one we'll use on exams. This gives you an idea of where to look. Finally, after you know where to look, do your equation and then check your solution. And ask yourself if this makes sense. The key part of physics is tying in this math to the physical world. So we want all of your answers to make sense to you. So let's take this problem solving out for a spin. So a ball is thrown horizontally off a 50-meter cliff. So we're going to draw this picture as we talk. Here's your person throwing this ball with v naught. And in this case, where it says horizontally, that means that this is your v naught x equals 18 meters per second. And this ball is going to go wee all the way down to the ground. So this right here would be your x initial, x final, y initial, y final. So let's write down everything we know. So x naught, not given to us, but we can put it as 0. X final, we don't know. V naught x. V naught x is 18 meters per second. Ax is equal to 0 because this is a projectile motion. We don't know time. V final x is 18 meters per second. This is because acceleration, if we look at acceleration, is the change in velocity. So if you have 0 acceleration, your velocity is not going to change. So let's look at y. Our initial y position, we start at the top of the cliff, 50 meters. You land at the ground. You're thrown horizontally, so there's no y component. And then we don't know your final y velocity, but we do know that since you're accelerating due to gravity, negative 9.8 meters per second squared is your acceleration in the y direction. All right, so let's look at this and solve part A. So a good thing to do now would be to pause the video, work the problem yourself, and then come back and we'll work it together. That way you can see what answer you get, what happens if you make a mistake. But it's good to try it first on your own. All right. So now that you've tried it once on your own, let's see what happens when we go through this together. So we're looking for time. We don't know what t equals. Now we can look at this x part of the equation, and going back to those formulas, take a look at them, see if there's anything that can help you there. All right, and then look at the y part, see if there's anything that can help you. And for this case, we're going to start with y. So we're going to start with the equation y minus y naught equals v naught y times time plus 1 over half ay t squared. And do we have any zeros? And our y final is 0, and our initial y velocity is 0. So what we get is negative y naught equals 1 over half ay t squared. If we solve this, we get negative y naught times 2 over ay equals t squared, which then goes to t equals square root negative 2 y naught over ay equals square root of negative 2 times 50 over negative 9.8 meters per second squared, that is meters, and you get t is equal to 3.19 seconds. So we can solve that for t. Now, very important, when we talk about your answer making sense, if you get a negative time, something is off. So always do these little sanity checks. So let's move on to part B. So on the final part of the equation, we're finding the ball's final velocity. Now when we say velocity, we mean final velocity and then some angle theta. So if we look at this, we'll have some Vx, and then we'll have some Vy, and we are finding this V and this angle theta. So let's start with the x, Vx, which is equal to V naught x, and since it's not accelerating, both of these are the same at 18 meters per second. Good, so we got that one. So if we're looking for Vy, Vy equals V naught y plus at, which look for zeros again. This is 0, you have an initial velocity 0. So we get negative 9.8 meters per second times 3.19 seconds. And when we do this math, we find that this is negative 31.3 meters per second, which makes sense because it's falling down. So now we go over to this triangle. We know V1 is 31.3 meters per second. We know that Vx is 18 meters per second. So we go to tangent, or theta, equals tangent Vy over Vx equals inverse tangent negative 31.3 meters per second, sorry about that scribble, over 18 meters per second. And you wind up with theta equals negative 60.1 degrees. That is part of the answer. And to find V is going to be equal to square root 31.3 squared negative 31 negative Vy squared, we're just using Pythagorean theorem, plus 18 squared equals 36.1 meters per second. And you need both of these parts right here and right here to be correct. So let's work through this example again, see how it goes. Now I'm going to start a next example, which is a little more complicated, involves a little more math.